This QuickLearn Bullet teaches you how to customize interest rate swaps by modifying several features, such as a forward starting date, and the use of different settlement frequencies between the floating and the fixed leg, and/or different day count conventions, and several other variations. We will begin with a basic 3-year interest rate swap that we constructed in the QuickLearn Bullet called Interest Rate Swaps, and customize it several times. We therefore remind you to review that particular bullet if you have not done so already before you tackle the present materials. In any event, we remind you that we priced the 3-year bullet swap with quarterly payments at zero profit for the dealer and found its fixed leg to carry an interest rate of 5.22%. We will use the same LIBOR curve in this QuickLearn Bullet, and will introduce each of the following features into our basic interest rate swap in succession: a profit margin for the dealer, a notional amount that changes over time, a forward starting date, and different settlement frequencies between the floating leg and the fixed leg, and/or different day count conventions as well. Suppose the dealer wants a profit margin whose present value is $375,000. For the dealer to make a profit when the client is paying fixed, the dealer would need to lift the fixed rate a little bit. In the table appearing now, the difference is calculated by subtracting the fixed leg PV from the floating leg PV. So you would want this number to become negative in order for the dealer to make a profit. Goal-Seek has led us to a solution that you see here of approximately 5.36%. Now assume that the original 3-year bullet loan that was being hedged with the bullet swap has been amended so that it now amortizes in its last year in 4 equal installments of principal. The borrower would obviously need the swap notional to amortize in parallel with the loan, otherwise it will find itself overhedged in year 3. You should note that the first reduction in the principal from 100 million to 75 million would not take place until the end of the first quarter in year 3, i.e. at the end of the 9th quarter. By the same token, the notional at the beginning of the 12th quarter is therefore 25 million rather than 0. This table modifies the previous one to include a new column with the declining notional amount. Due to space restrictions, we have now hidden the columns showing each period's number and the discount factors as well. Working as before and using Goal-Seek, we have obtained a fixed rate for the amortizing swap of 5.05%. We observe that the declining notional in the last year means that the highest LIBOR forward values will now be receiving in the calculation a lower weight than they would under the bullet swap, bringing the all-in swap rate down. Therefore, we can generally expect that when the curve is upward sloping, the swap rate under an amortizing swap will be lower than under an otherwise identical bullet swap. And by the same token, we would expect the swap rate under an amortizing swap would be higher than under an otherwise identical bullet swap if the curve is inverted. A swap whose notional increases over time is usually called an accreting swap, and is often used to hedge a construction loan or a project financing whose debt is typically drawn in several stages over time as the construction or the project progresses. A swap of this kind behaves in a way exactly opposite to an amortizing swap. Specifically, an accreting swap would have a higher rate than a bullet swap in an upward sloping curve environment and a lower rate in an inverted curve environment. These four results can be summarized in the following table. Next, we assume that the borrower has obtained a commitment for a 2-year bullet loan instead of one for 3 years, but will not draw on the loan until exactly 1 year from today. The swap that would enable the borrower to lock in a fixed rate from the moment the 2-year loan is drawn, i.e. 1 year from today, has the self-explanatory name of forward starting swap. The only real difference when pricing a forward starting swap is that the notional in the table would be set to 0 until this forward start date. Therefore, in an upward sloping curve environment, a forward start swap will have a fixed rate that exceeds that of a spot start swap, since the LIBORs with the lowest values in the curve will receive weights of 0, causing the average to rise. And the opposite will be true when the curve is inverted. We illustrate all this on this slide, where you will observe that the only changes we have made from our very original table are to set the notional for the first 4 quarters equal to 0. This lifts the swap rate, as you can see, up to 5.86%. The last amendment involves a change in the frequency or day count convention of one of the 2 legs. This is tedious but necessary, since this is very often how a swap works in real life. The borrower, for example, may have a fixed rate 3-year bond outstanding, paying semi-annual coupons under a 3360 convention, and would like to compare his effective fixed rate under the swapped bank loan to that under this bond. Unless the fixed leg under the swap also has a semi-annual frequency and a 3360 convention, the comparison would be inaccurate. The floating leg of the swap, of course, would not be amended in the same way, since that leg needs to match perfectly the frequency and day count of the bank loan, which is often quarterly and invariably based on an actual 360 day count. The table appearing now contains all the necessary amendments. Note the 3360 convention in this column here within the formulas, in contrast to the actual 360 convention for the LIBOR payments in this column here. Note also the key difference in the payment frequencies between this column, which shows quarterly payments, and this column, which reveals semi-annual payments. The new 3-year bullet swap rate comes to 5.33%, which is higher than the original 5.23% reproduced in this table here, our original table. This completes this QuickLearn Bullet on customized interest rate swaps.